In this circuit, we have two resistors connected in parallel. R1 is 20 ohms and R2 is 25 ohms, according to the manufacturer's specifications. The equivalent resistance R of this arrangement are related to R1 and R2 as such. Now, since there is possibly manufacturing variation, the actual resistance might deviate from the design value. So here are two questions. First, we would like to know if R is more sensitive to variation in resistor R1 or R2. Second, if R1 is off by a positive 0.1 ohm and R2 is off by a negative 0.1 ohm, what is the percentage change in R from the value that we expected? Let's get to it. To answer the first question, we may compare the two partials of R with respect to R1 and R2. We can compute the two partials using implicit differentiation, since we have an equation that defines R implicitly as a function of R1 and R2. Or we can deduce the two partials from the total differential of R. The two approaches involve pretty much the same amount of work, but we'll go for the second one. As a heads up, this is because we will use the total differential of R to help us answer the second question. So let's get started with the relation of R with R1 and R2. Take differential of both sides. We get this. By sum or difference rule for differentials, we can split the right-hand side differential into two. Now we end up with three differentials of a reciprocal function. The results are going to be in the form of -1 over something square times d something. So on the left, we have this. Notice that the dr here denotes the total differential of R that we're after. Now here is the first one on the right, and here is the one that follows. Multiply both sides by -1, and then by R squared too. So here we have the total differential of R. From the dr1 term, we get partial R1. And from the dr2 term, we get partial R2. Now since R squared is positive, R squared over the square of 20 is greater than R squared over the square of 25. That means partial R1 is greater than partial R2. And so we conclude that R is more sensitive to variation in R1. Nice! What about the second one? Remember, I've told you up front that we're going to use the total differential of R to answer the second question. So here is how. To figure out the percentage deviation in R, we basically just need to compute the relative change in R, which is absolute change in R over R. Now, if we divide through the equation for the total differential of R by R, we can relate dr over R to dr1 and dr2. Replace all three differentials with increments, we get an approximation formula to compute the relative change in R. Look at the right-hand side. We have the numerical values for all pieces except R. So let's compute it. Plug in the values of R1 and R2. R is 100 over 9. Back to the approximation formula. So delta R over R is 1 over 1,000. That means there is a positive 0.1% deviation from the expected R value. All right, problem solved. I hope you enjoy this video, and I'll see you in the next one.